Okay, so today you're going to be able to solve equations that require simplification by collecting like terms or by using the distributive law before you isolate the variable. So these are more complicated equations with more steps involved to isolate the variable. So what happens when there's more than one term with x? Oopsie, dear me. So in that case, you're going to have to gather up your like terms and I'm just going to get rid of this if I can. Gather up all of your x's before you isolate the variable, because there's more than one variable. Okay, to solve an equation involving multiple like terms, move the variable terms on one side of the equation and the constant terms on the other. Okay, so you want to get x's on one side and numbers on the other side. Of course, we have that golden rule of algebra. Again, I'll just remind you, what you do to one side of the equation, you must do to the other side of the equation. So when you're solving equations with variables on both sides, you're going to remove any brackets. You're going to use opposite operations to move variables to one side and constants to the other side. You are going to collect like terms, and again you might have a coefficient in front of your variable, so you're going to again use opposite operations one last time to isolate the variable. And the other thing that you might want to do is up here is remove any brackets and simplify on each side of the equal sign first. So in other words, if you had something like 3x plus 2x equals 5, you want to make that 5x first before you do anything else. Okay? So remove brackets and then simplify on each side before you start moving things around. Alrighty, so let's do some examples. See, I've got two x's here. I've got the 5x term and I've got the minus 4x term. So I can do one of two things. I could subtract 5x from both sides to get rid of the 5x over here and just have x's on this side. Or I could add 4x on both sides to get rid of the 4x term on this side and introduce the 4x over here. And so I would end up with x's over here. I can do one or the other. It doesn't really matter, except that looking ahead, I know that if I am adding 4 to both sides, then this is going to be a positive number. If I were to subtract 5 from both sides, I would end up with minus 4x minus 5x. And then I would just have a negative coefficient in front of my x, which I'm trying to avoid. So that's the only reason I've chosen now to do to add the 4x to both sides. So I've got 5x minus 3, and it doesn't really matter where you add the 4x on the left hand side as long as it's somewhere in there. Sorry, I didn't line up my equal signs very well. And this is going to be 2 minus 4x plus 4x. All right. Then when I can simplify that now, and that's going to become 9x minus 3 equals 2. And then I want to get 9x by itself, so I have to get rid of the minus 3 that's being subtracted from that term. So I'm going to add 3 to both sides. Let's see. So this is going to be 9x minus 3 plus 3 equals 2 plus 3. I'm trying to be so fancy with the colors. Okay, so I added 3 to both sides. All right, so then we're going to have 9x equals 5. And now I'm going to try and get rid of the 9 that's being multiplied by the x by, of course, the opposite operation of multiplication, which is division. So that's going to leave me with the x here, because 9 over 9 is 1. And of course, we just leave this as a fraction. Now, it didn't say check, but if we wanted to check, we would just rewrite the whole equation out and substitute in 5 over 9 wherever there's an x. We don't move anything around the equal signs during our check. All we end up with is the left-hand side, and we figure out what the right-hand side is as well. So this, I'm multiplying my fractions, and this is going to be minus 2 over 9, I believe, and this is going to be 18 minus 20, which is also minus 2 over 9. So left side equals right side. Okay, so I know we are correct with our answer, x equals 5 over 9. Okay, so now if we have equations with brackets, you want to expand using the distributive law. Then you want to continue with the steps above, but I think I did right. Didn't I say remove any brackets? Yeah. Okay, so we've got brackets obviously, so I'm just going to expand this out. So this is going to be 15k when I multiply the 5 by the 3k and the 5 by the 2. And that's plus 2, so that's plus 10 equals 3k minus 3. So now I think I will subtract 3k from both sides, so I end up with 15k minus 3k plus 10 equals 3k minus 3k minus 3. So I subtracted it in a different spot this time, and I didn't change the color, but this is the minus 3k that I'm subtracting from both sides, obviously. And now I end up with 15k plus 10. No, I don't. I'm sorry. I end up with 12k. This should be, let's see what happens here when I do that. It's going to be 12k plus 10 equals minus 3. Now I need the k by itself over here, so I've got to subtract off 10. So it's going to be 12k plus 10 minus 10. And I'm subtracting that 10 off of both sides. So this is going to be 12k equals minus 13. And last step, of course, is to divide both sides through by that coefficient in front of the variable k. So this is k equals minus 13 over 12. I won't check that one. Okay. So a little more complicated, but the steps are really just the same, and the end game is the same. You want to get your variable isolated. You want to just have one letter, no coefficient, not even a negative in front of the letter as your final answer. All right, so I want you to pause the video now and practice these two, please, and then come back on and see if you got it right. Okay, so what I'm doing for this one is I'm simplifying first as much as I can on each side of the bracket. So this is minus x when I combine these x's. This is 4x. And now I'm going to either add x to both sides to get rid of that one, or I could subtract 4x, which is probably what most of you did, so I will do that. So minus x, and then I'm subtracting 4x. And I've got my 4x here, and I'm subtracting 4x. Okay, so I subtracted 4x from both sides. This then becomes minus 5x plus 2. This disappears, and I get 17. So now I need to get rid of that plus 2 on this side, so I'm just going to have minus 5x plus 2 minus 2, and that's going to equal 17 minus 2. All right, when I clean that up, this is going to be minus 5x then, the 2's disappear, equals 15, and hopefully, and now I'm dividing by minus 5, be careful about that, it's not 5, it's minus 5, and my x is going to equal negative 3. Okay, now I'm going to have Distributive law over here. Oh, it said to check. Better do that. Sorry, let's go back to this one then. The most important thing when you're doing a check is that you are going back to the original equation that was provided. And I'm not going to have enough room here, so I think what I'll do is I'll just cheat and use the space for the other question and then erase it. Okay, so my check for this one is going to be 3x minus 4x plus 2 equals 6x minus 2x plus 17. All right, so I substitute everywhere in. I can't simplify this equation, so I just substitute in everywhere there's an x. So this is minus 9 plus 12 plus 2 minus 18 plus 6, because I have a minus times a minus. Sorry, that's my phone. Hopefully my husband will get it. This is 14 minus 9 is 5. And this is minus 1 plus 6, which is 5. And left side equals right side. Okay, so that check worked out. All right, I'm just going to erase this one. Hopefully you can go back to it if you're having any difficulties with it. And we'll do the other question. Okay, so the next one, you're just expanding out. You have to get rid of the brackets first. So you're going to end up with 2a minus 16 plus 3a plus 18 equals 17. So everything's on the left-hand side here. So let's see what we'll gather up our like terms. So 2a plus 3a is 5a. And minus 16 plus 18 is 2. So plus 2 equals 17. So this actually distilled down to a pretty easy question. Then I've got my 5a plus 2, and I want to get rid of what's attached to the 5a. So of course I do my subtraction, minus 2 on both sides. So I end up with 5a on this side and 15 on this side. And when I divide through by 5 on both sides, I end up with a equals 3. That was a pretty easy one actually. And if I check, I got to go back to this. So this is going to be 2a minus 8 plus 3a plus 6 equals 17. If I stick in the 3 for a, let's see if left side equals right side. Remember, don't start doing your distributive law at this point. You have to follow the rules of BEDMAS. The BEDMAS says, oh, let's simplify inside brackets first. So 3 minus 8 is minus 5. 3 plus 6 is 9. Let's see what that works out to. That's minus 10. 3 times 7 is, or sorry, 3 times 9, sorry, is 27. And 27 minus 10 is 17. So we do have left side equals right side, and we know our answer is correct. Okay, we're going to do a little bit of problem solving here for this next one. You've got two consecutive integers that have a sum of 35. What are the integers? Now, you have to remember that for these types of problems, you're not just coming up with an answer. You are showing a full algebraic solution. So really follow along with these steps, please, so that your solutions look quite similar to mine. And so here's a quick problem-solving algorithm, if you will, or just steps that you can take whenever you've got kind of a word problem, because typically word problems are the hardest things for students. So understand the problem. Well, what that means is go to the problem, look at some of the key words here that you might be able to use, or might be able to sort of refresh your memory on, or just even to read twice so that you know that it's an important part of the question. So I see the word consecutive. So I'm going to write that word down, and I'm just going to refresh my memory. Consecutive means one after the other. Okay, so we've got that in the back of our mind when we start thinking about other things. I see the word integer. Okay. Let's just refresh my memory about what an integer is. An integer is a positive or negative whole number. Okay, so some examples would be plus or minus 2, but it's not a fraction, it's not a decimal. Okay, so an integer. I see the word sum. We could refresh our memory about sum. Sum is the result of addition. Okay, so I've kind of just made sure I've thought about a few of the key words in there. Okay, now choosing a strategy. I'm going to declare a variable, and I'm going to use the variable to determine an equation involving the integers in the question. So that's my strategy. I'm going to see if I can come up with a variable and an equation. So let's carry out the strategy. All right. So it says that two consecutive integers have a sum of 35. All right. I think I should let x then represent one of my integers. Now, I can't just say one of the integers. I need to be more specific. So I'm going to say let x represent the smaller integer. Okay. So now I'm just going to write an expression before I write my equation. So the smaller integer, we can express that as x, right? And the larger integer, no, we don't want to use y, we don't want to use another variable, we want to use this variable, so this represents the smaller integer, and what do we know about the other integer? It's bigger, yes, but by how much? By 1, right? Because of the word consecutive. So this is how we would get the next consecutive number after our x. If x was 5, the larger integer, of course, would be 6. Okay, so now that I have two expressions, remember these are expressions, not equations, because they don't have an equal sign, I'm going to come up with an equation that relates these two expressions. Well, what is it about these two? This is the smaller number, this is the bigger integer. What do I know? Go back to the question. It says the sum of the two consecutive integers is 35. So I can say the smaller integer plus the larger integer is equal to 35. And if I only have one variable, in other words, like an x or a y, and I can have more than one x or more than one y, but I can't have an x and a y in one equation. If I have more than one x or more than one y, if I have an x and a y, then it becomes just a relation. I can't solve it. So if I wanted to solve this now, I'm just going to add my x's together, simplify this as best I can, and now I need to isolate my variable. I'm not guessing at the answer. I'm undoing what's been done to the x in order to find out what x equals. So I can see here that I have to subtract 1 from both sides. Oopsie, shouldn't have done that. Do that. So I subtract the 1 here, and I'm going to get 2x equals 34. And of course, then we're just going to divide both sides through by 2. So my strategy was to solve for x, which I did, but I need to reflect on really what the question was asking me. So the last thing is to reflect on your answer. My answer is 17. Have I answered the question is the question. Let's go back and read it again. Two consecutive integers have a sum of 35. What are the integers? Not integer. So this is the smaller integer that I have found because that's x. That's what we let x represent. The other one is x plus 1. So then I would just stick the 17 in there and add 1. So x plus 1 is 18, obviously. And Our reflection will also include our little therefore statement. The two integers are 17 and 18. And we might want to, in the reflecting, we might want to think about checking it as well. We could always go back and check and see if they add together to give you 35, which was what it said in the original problem, right? And of course, 17 plus 18 is 35. So you always go back and make sure that you've read the question. All right, so that's a little problem solving strategy for you. Problem number 2. Why don't you pause the video and see if you can come up with a solution for problem number 2, and if you can't, come on back and I'll do it for you. Okay, so what I've got here, it says a square has sides of length 2k minus 1. So all of the sides of a square, of course, are the same length. An equilateral triangle has sides lengths of k plus 2, and it says the square and the triangle have the same perimeter. So if we're doing, again, trying to understand the problem, we're making sure that we look at things like the word square, and you might say 4 equal sides. You might look at equilateral triangle, I was writing equivalent, I think, equilateral triangle, 3 equal sides. We know that both perimeters are the same. What else do we know? Yeah, that's about it, right? And so, how are we going to find k? Well, I'm going to use my p for perimeter, and I'm just going to say that the perimeter of the square is equal to, well, 2k minus 1 plus 2k minus 1 plus 2k minus 1 plus 2k minus 1. The faster way of doing that is 4 times 2k minus 1. And I know the perimeter of the triangle, so I'm just not writing p because then I wouldn't know which one this one represents. So 3 times, k plus 2. Okay, so I have an expression for the perimeter of the square. I have an expression for the perimeter of the triangle. And now I need to relate them. Well, I know that they're equal because it tells me that both perimeters are the same, which means that I can say that 4 times 2k minus 1, which represents the perimeter of the square, is equal to 3 times k plus 2, which is the perimeter of the triangle. 2k minus 1 is not equal to k plus 2, okay? It's not the side lengths that are equal, it's the perimeter. Okay. And just do the math here. So super easy because we're just going to distribute and then rearrange. So this is 8k minus 8, my bad. It's 8k minus 4 is equal to 3k plus 6. Okay, so I'm going to move that 3k out of there, and it's going to end up being minus 3k on both sides to balance the equation. So 8k minus 4 minus 3k, equals 3k minus 3k plus 6. I didn't use red this time. Hopefully that's okay. So 8k minus 3k is 5k minus 4 equals 6. So now I need to get rid of that minus 4 on that side. So I am going to add 4 to both sides. So this is 5k minus 4 plus 4 equals 6 plus 4. All right, so what do we end up with? This is going to be 5k equals 10, and of course, k equals 2. All right. Okay, so I got a value for k, and so I should make a conclusion here, therefore, the value of k is 2. I should also just go back and check and see if I answered the question that was asked. What is the value of k? Because this could have asked, well, what is the perimeter of the triangle? Or what is the perimeter of the square? Once I got k, I could figure out what the perimeter of the square was. I would just stick 2 in here for k and figure out what this is. Or I could do the same thing here. I could put 2 in here for k and get that the perimeter was 12. Okay, 2 plus 2 times 3. So just always make sure that you are reflecting, you're going back, you're asking yourself, does the answer make sense? And you are answering the question that was asked. Okay, guys, that is it for the lesson.